For my signal generator project, this is the function generator that I've built from the kit recently. I'd like to power it by batteries for various reasons, and so I thought I would make up a pack of 3 of the lithium ion cells. So these are nominally around the 3.6, so it should give us around the 12 volts needed to power this guy. So they're just wired in series, and we've got a suitable plug there, and we can see that it all works well. So I'm going to build this into a case and put this battery pack in there. But obviously I need some means of charging it. So these cells are, remember, unprotected. So if something goes amiss, they're overcharged or misused in some way, they could go bang or cause some other problem. So what we need is a way of protecting these cells. So here is a battery protection circuit. Now you can buy these boards in various configurations. This one is specifically for the 3-cell version, and excuse me, on the Banggood website there seemed to be a degree of confusion as to what the board does and what it doesn't do, and more basically how it's wired up. Now I'm guilty that don't really think about the days when these things were complicated for me as well. So it's not immediately obvious from the diagrams which are on the website how this thing is wired. So I just thought I'd explain that. Now we saw that the cells are sort of top and tail, so with positive of one it goes to the negative of the other, positive to negative, and finally out there, so that we can see that as far as the battery is concerned, this is a positive lead coming from the last positive cell, and at the end of the loop we have the negative terminal going to the third battery. So they are clearly going to go to the battery negative and battery positive. If you just think of it that the only things that you ever connect to the battery terminals are batteries, then you can't go too far wrong. So that means that the 2 central pads, the P- and the P+, are both used for either charging or discharging. So that's either for powering the load or for charging the unit. And the unit is driven by a dedicated controller chip there that works those things out for itself. The other part of the wiring you have to concern yourself with is how to measure the board needs to know how to measure the individual cells. So that's why at this location here we have VH, VM and VL. Now VL is not used on this, that's reserved for the 4-cell variant of this, and there'll be more on that in a different video. Suffice it to say that VH goes to the negative end of the last cell. So here's our positive, so that goes to the negative, so that's analysing that battery. So that's the first battery. The VM, the middle if you like, so high, middle and low, that goes to the negative side of the second cell, and clearly the third cell is connected down here to the negative terminal anyway, so that is being monitored. So it's pretty clear that the cells have to be wired in that manner. As for what this board is and what this board isn't, the description is fairly clear as to what it does do. What it does, it protects the cells against overcharge, it protects against over discharge, over current, and importantly short circuit protection. And it does all this automatically, and there's also another red herring called automatic activation, but we'll come on to that again in a different video. So this is just a battery protection board. It is not a charging board per se. Now you can, just by applying a suitable voltage to it, it will provide the charging function, but it has no control over, for example, the input current, which will be dependent upon the voltage. So you have to be a bit careful there, and really you should connect a proper charger to this board rather than just a power supply. I'm going to demonstrate that now by hooking it up to my venerable Astroflight meter, and then we'll talk about what that is going to measure. So if I plug the power into one side, the load side of the we'll call it the power meter at the top, we can see that the pack is currently reading 11.2 volts, so it's in need of a charge, and obviously there's no current flowing into it at this point. If I disconnect the pack and then power the meter from the supply that I'm using, we can see that the input voltage is 12.6, and again at this moment in time there's no power flowing. So 12.6 is correct for 3 cells at 4.2 volts. But as I mentioned before, you have to rely upon the charger to do any current limiting. So if you had a significantly higher voltage than that, then you would be drawing too much current. So with the charging voltage applied, if I now connect up the load, the batteries to be charged, we can now see on the meter at the top that the charge current is 0.7 of an amp, and that the voltage is now climbing to meet the 12.6. So at the moment the cells are effectively in their constant current phase. Now this is obviously going to take a little while, but you can see the ampere hour count there as well. So we'll see what happens once the charge condition is met by the protection board. So here we can see that the current has dropped to 0, and this is the input voltage of 2.7. It begs the question as to whether the board has actually disconnected the charging, or it's just because the voltages are now the same. Now we can easily test this with the voltmeter here. So what we have across the battery is in fact 12.48. So it has actually disconnected the battery. So the charging FET on the board has switched off, and we can prove this if we monitor on here. This again is the input voltage, 2.8, and the battery voltage, 12.47. So clearly it has disconnected the load, the battery, from the charger. So having switched the charging voltage off and left the unit overnight, we can now see that the battery voltage has dropped to 11.8 just by sort of self-discharge. And if we monitor the individual cells, we can see that the first cell 3.977, the second cell 3.947, and the last one 3.939. So they're not. This is not a balanced charging board. It's not designed to do that sort of thing. It is purely a protection board, provided that you select an appropriate voltage, which could be between 10.8 and 12.6, depending upon the exact cells that you're using. You can use this as a sort of pseudo charging board just by applying a voltage to it, but I would highly recommend that you use a proper lithium charging circuit with a constant current, and just leave this board to do what it was designed to do, just to protect the cells from overcharge and over discharge. So I hope you found that useful, and I'll provide links in the description as usual to all the relevant tools and parts.